have an idea of what it needs to look like. Okay, so degrees, you know, this is 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and then this would be 360. Okay? Do y'all remember that? Okay.
What I did was I put 0 and 360 on the same box.
Oh, that's fine, as long as you understand, okay? Now, what we're going to do next is we're going to list the exact values of these points, right? Like the coordinates of these points. So we know that this is the square root of 3 over 2, 1/2, right? And if this one's the square root of 3 over 2, 1/2, so is this one. We'll get to the signs in a second, okay? Are there any questions so far? The next, we know that this one is square root of 2 over 2. And so are all of these in the middle, right? Some of you guys accidentally put the square root of 2 over the square root of 2, square root of 2 over 2. Okay, and then we also have our 1/2 square root of 3 over 2. Okay, we can look at our signs now. So, first ones are negative here. Both of them are negative here. And the last one's negative here. And then only thing we have left to do are points on our axes. So this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, are there any questions there? I understand that I did that pretty quickly, but I would say most of you need to be able to do that in about 3.5 minutes to go around, and I think that's doable because we just did it in 2.5. Okay. Now, once we know the angles, guys, we could find the radians. I'm not going to make you do that right now, okay? What we're talking about today is we're going to be talking about exact values, and it wants to know what the exact value is at that point. So if I asked you for something like the sine of 30 degrees, okay, so imagine this is an example problem, the sine of 30 degrees, okay? Let me make that bigger. So what that means is we want to go to 30 degrees, and we kind of want to look at this triangle right here. Okay, do you see this triangle? This is our 30 degrees. And do you remember what sine is? Sine is what over what? SOHCAHTOA. Opposite over hypotenuse. Good. So how long is this side? It's the long side, but what's its exact length? Square root of 3 over 2, okay? Because we know we go over square root of 3 over 2 because that's the x-coordinate, and we go up 1/2, right? So the sine of 30 is our opposite, which is 1/2, over our hypotenuse, which is, what's our hypotenuse? For a unit circle? 1. Do y'all remember that? But that's just equal to 1/2, correct? Now, we don't have to actually go through all this, right? Because no matter what, it's always opposite over hypotenuse, right? The y-coordinate of our points, that's going to be the sine. Does it make sense? Because we're just going to do the opposite over 1. So every time, like, what's the sine of 45 degrees? Good, let me draw some cards. Okay, give me 1 second. Jada, what is the sign of 45 degrees? Good. Patricia, what is the sign of 60 degrees? Okay, well, if we looked at this 60-degree one right here, we go over 1/2, and then we go up square root of 3 over 2. So if this is 60 degrees, it would be the square root of 3 over 2 over 1, which is just right. So can we come to some conclusion here, instead of us having to do this every time? What? The y value, you mean, right? Right. So the sine of 80 angle is just going to be that y value. Well, let's say I gave you the sine of, I asked you what the sine of 2 pi over 3 was. All we would have to do is convert this to what? Degrees, right? And we can easily do that, can't we? How would I convert this to degrees? Yeah, we would multiply this times 180 over pi, and what would that give us? So we'd have the sine of 120. So we go over to 120, and the sine is the second one, so it's what? Square root of 3 over 2? Are there any questions? Is that pretty easy? Yes, ma'am. Well, we're going to get there. All we're doing is we're using what we know about the triangles, the unit circle, with what we know about triangles and SOHCAHTOA. Okay? I think maybe you did. Look at this purple triangle. Do you see how this is a 30, 60, 90 triangle? It asks for the sine of 30. Remember, sine is opposite over hypotenuse. So here, opposite is 1/2, and the hypotenuse is 1. Do you know how we knew that? Opposite and hypotenuse? But do you know how we got this 1/2 and the square root of, or the 1/2 and the 1? Okay, so then the 1. Because remember, in a unit circle, the radius is 1, because it's called a unit, and the radius is 1 unit. So that's how we knew it. Or we could have used the Pythagorean theorem with the square root of 3 over 2 and 1/2. We would have, which we don't really want to because that's kind of ugly, we would have gotten 1 as our answer. If we did a squared plus b squared equals c squared. Okay? So, now, what do you think is going to be true about the cosine? It's going to be the x, right? Do y'all want to see that it's going to be the x, or do you believe me?
I can see it.
You can see it because it's, in this time, it's adjacent over hypotenuse. But regardless, the hypotenuse is still what? 1, right? Regardless, the hypotenuse is still 1. So the sine is just going to be the y, and then the cosine is the x, right?
Yeah.
Now, what about the tangent? Let's look at the 30, 60, 90. The tangent, if I asked you for the tangent of 30 degrees, right? The tangent is opposite, which is 1/2, over adjacent, which is the square root of 3 over 2. This would actually give us, so this is going to end up being uglier than I thought. This is the tan of 30 degrees is equal to 1 over the square root of 3. But what's wrong with this? Right, so what would we need to do? By the square root of 3, right, multiply by the square root of 3 over the square root of 3. And we get the tan of 30 degrees is equal to the square root of 3 over 3. Okay? So we could do this every time where we'd set up the triangle and say opposite over adjacent. But what we see is that the tangent every time is just sine over cosine. Okay? The tangent is just your sine over your cosine. Does that make sense? Your sine value over your cosine value. or your y value over your x value. Do you guys see this? I have this written on the board. Y'all can't see it, but I will write it on here so everybody else at home can. And that is that the sine, or the cosine, is equal to x, right? The sine is actually going to just be your y. The tangent is equal to what? Y over x. Now the secant, which is actually the reciprocal of the cosine, that's equal to 1 over x. The cosecant is equal to 1 over y. And the cotangent is equal to x over y. And you know your unit circle, you should be good. Okay, let's do a few problems together.
Let me write this down.
Okay. You don't have to write it down right there. It's up on the board. And I want to get through a few more things, okay?
Okay.
All right. All right, here we go. Number 1. Miguel, what is the sine of 30 degrees? Does everybody agree with Miguel that it's 1/2? Alexia, can you see that the sine is 1/2? Tiffany, do you see that the sine of 30 degrees is 1/2? Alexia, be honest with me. Mhm. Okay. Chloe, how do we find the tangent of pi over 4? Okay, well, first thing we need to do is make pi over 4 into a degree, right? So how would we do that? We'd multiply by what? Very good, 180 over pi. And what's that going to give us? Okay, and what's 180 divided by 4? Anybody else? Think about 180 divided by 2 is 90. 90 divided by 2 would be 45. Good. So what's the tangent of 45 degrees? Tangent is sine over cosine. What's the sine of 45 degrees? Okay. So this is your cosine sine. And at 45 degrees, what is that? What is this point at 45 degrees? Okay, so it doesn't really matter at 45 degrees because they're the same, which means tangent of 45 degrees is what, Chloe? What? 1. Good. All right, how do y'all feel about that? Okay. All right, at this time you may pack up. Your homework is to turn this over and try to write the unit circle on the other side without looking. And you remember, you don't have to do the radians as long as you make sure that you get the degrees as well as the coordinates correct, okay?
So the homework is to do what we practiced?
Yeah, just practice it again on the other side, okay?
Okay.
And it shouldn't take you more than 3.5 minutes, okay? Daniel, you're going to have to come to me after 7th period. Hold on one second, I'm still recording. Hold on one second, please.